Good day everyone, my name is Jericho Jose from BIT2K, here to explain to you things you need to know about crankshaft and camshaft position sensor. Crankshaft position sensor. What is a crankshaft position sensor? A crankshaft sensor is an electronic device used to monitor the position or rotational speed of the crankshaft. This information is used by engine management system to control the fuel injection or the ignition system timing and other engine parameters. Purpose of a crankshaft position sensor. A crankshaft sensor can be used in conjunction with a camshaft position sensor to monitor the engine's piston-valve relationship, which is especially significant in engines with variable valve timing. This procedure is also used to synchronize a four-stroke engine when it first starts, allowing the management system to determine when to inject gasoline. The main crank pulley, the flywheel, the camshaft, and the crankshaft itself are all common attachment points. It is also widely used to determine engine speed and revolutions per minute. The sensor, together with the camshaft position sensor, is one of the two most critical sensors in modern engines. To determine the position and/or rotational speed of the crank, engine control units use the information transmitted by the sensor to control parameters such as ignition timing and fuel injection timing. This sensor output may also be related to other sensor data, including the cam position, to derive the current combustion cycle. This is very important for the starting of a four-stroke engine. Purpose of a crankshaft position sensor. Types of CKP sensor. Inductive sensor, Hall effect sensor, and optical sensors. Construction of a crankshaft position sensor. Inductive sensors have a coil of a wire that can detect the passage of marks as an inducted current. From physics class, from physics class, a changing magnetic field near a conductor, such as the passing of a metal tooth on a reluctor ring, induce a small current into a nearby conductor. On a turning reluctor ring, a graph of this induced current against time looks like a sinusoidal wave racing as the tooth approaches and then dropping as it passes. So you can see here the housing, magnet, and the bobbin with the copper windings. The magnet goes inside there and the shell. Hall effect sensors. Hall effect sensors are also inductive, though they produce a square wave instead of a sinusoidal wave as the tip of the reluctor ring passes by. The Hall effect sensor typically consists of a transistor acting as a switch. So here's a basic one. This is the reluctor ring that we are talking about. Air gap and permanent magnet, and instead of a coil, this one has a Hall effect sensor, but this does still have the magnet. And this one also have a three-wire sensor signal, supply voltage, and ground. More on this later, in later slides. Optical sensor consists of a photodiode, LED, and a slit disc in between the two. And this is usually inside the distributor of a engine. So engines that still uses distributor and not coil on plug usually have this type of position sensor. More on this also later. The sensor are usually a two-wire device, however, some sensors have three wires, the third being a coaxial shield wire to keep out any interference that may interrupt and corrupt the signal. So, usually a inductive type has two wires, this one, the twisted wire, and the Hall effect type have coaxial shield wire. And now we will know why, because the next slide is operation of a crankshaft position sensor. First off, inductive sensors. On a turning reluctant ring, a graph of this induced current against time looks like a sinusoidal wave racing as the tooth approaches and the dropping as it passes. So For a better visual representation, this is the coil, winded coil, permanent magnet, and this is the sensing teeth or the reluctor ring. This is a sample graph of a magnetic crank. And as you can see, this looks like the waves of a BPM of a hospital, as you've seen in hospital, the beep, 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 those types of things. That's how it is. As it reaches the peak of the teeth, after that it drops suddenly in voltage and raises again, and it repeats itself as a cycle. That's how it detects the position of the crankshaft. Oh, and by the way, there is there are usually two teeth missing here to indicate the degrees of the crankshaft, in which it could be in top dead or bottom dead center of the first cylinder, because usually that's the first cylinder to fire. Next. One of the main advantages to the inductive sensor is that it is totally passive. Its signal is derived entirely from the induced current, meaning no external power source is required for the sensor. Having said that, sometimes this signal is amplified and the amplifier will require an external power source. So this is what I was talking about, the two wire. The variable reluctor sensor or the inductive type only needs two wire, which is going to the signal, and one in return, which is ground, meaning this is a basic diagram. Okay. Hall effect sensor. When the teeth are close enough marks to magnetically induce a current, the transistor acts as a closed switch allowing current to flow. When the teeth are farther away, the magnetic field decreases and the transistor acts as an open switch preventing current to flow. So, unlike in inductive, the Hall effect sensor here has a transistor that acts like a switch. And when it detects the reluctor ring or the gear in the top, it will act as a on switch to keep it steady and suddenly turn it off once it passes the teeth. So it makes a Hall type effect in the graph, as you can see here. So 5 volts is when it's in the top, and 0 volts when it's in no teeth at all. Hall effect sensors must be powered, which is another primary difference from inductive sensor. The transistor must be powered externally, where the induced signal merely opens. Hall effect sensor must be powered, which is another primary difference from inductive sensors. The transistor must be powered externally, where the induced signal merely opens the switch to let the current flow from the external power source. Depending on the configuration, this is either a gate current, MOSFET, or a base current, BJTs. So, based on my readings, this Hall effect sensor is a more reliable one because unlike the inductive, which has really a advantage of not having an external power, it's not quite reliable because usually when the magnet is worn out or doesn't have charge anymore, it cannot function properly. Unlike the Hall effect sensor, it has an external power, so the magnet does not need to work twice as hard, and there's also a separate switch, which is the transistor that gives the signal to the ECU, and it uniforms the signal, sending it to the ECU. As of my understanding, that is optical sensors. Optical sensors have two varieties, active and passive. Active sensors must transmit a continuous or pulsed light source and then wait for the reflection. Depending on the time elapsed, the optical sensor can determine whether they are at or over a mark or a space, or look for the rising or falling edges as the wheel turns. So Unlike the inductive and Hall effect, the optical type is quite unique as it uses light and photodiode instead of a magnetic field. Passive sensor looks for a reflection or changing in light as the marks and spaces passes by. So unlike the active sensor, the passive one just needs to see if the light will pass at that specific time. And that will be the indicator it's in if it's in position. The positioning I mean. Optical sensors. The big limitation for optical sensor is their need for a visual path. They must maintain a certain gap from the reluctor just like all of the other sensor, but they must also be able to see the reluctor. This becomes a problem if the lens of the sensor or the reluctor ring became dirty or oily. Many of these have a dust-tight housing to prevent contamination, but it still occurs. Because of this, optical sensors are less common in automotive applications. Camshaft positioning sensor. What is camshaft position sensor? The task of the camshaft sensor is to work with the crankshaft sensor to define the exact position of the crankshaft drive. It also tells the position of the camshaft inside the engine and relays it to the ECU. Purpose of a camshaft position sensor. So the combination of both sensor signals, the engine control unit knows when the first cylinder is in the top dead point. This information is needed for three purposes. One, for the start of injection during sequential injection. Two, for the actuation signal of the solenoid valve from the pump nozzle injection system. And three, for cycle selective knocking control. The cam sensor can be used in combination with a similar crankshaft position sensor to monitor the relationship between the piston and valve in the engine, which is particularly important in engines with variable valve timing. Types of CSP sensor: inductive, Hall effect, and AC output. Construction of a camshaft position sensor. Inductive and Hall effect sensor, as stated in previous slides, beside being similar to a crankshaft sensor, so as the build of these types of sensor in the camshaft with the exception the AC output in which we would read about the next slide. AC output. This disc is mounted on the end of the camshaft and has a slot with it. When the slot passes through the coil, it excites by mutual induction and a signal indicating the position of the first cycle is sent to the ECM. So, unfortunately, I cannot find any type of pictures, though I have found a reading of what a AC output looks like. Operation of a camshaft position sensors. In consecutive, oh, sorry. In consecutive fuel injection systems, ECU must determine which cylinder to fire next. This information is provided from the cylinder identification sensor. During the engine rotation, the sensor sends a signal to the onboard controller wherever the first cylinder is at the top, dead center. Thus, the duration of the pulse injection is estimated. In simultaneous fuel injection systems, the onboard controller does not identify the cylinders and the firing order because this is not necessary for the system to operate. When a crankshaft or distributor advanced ignition signal appears, the exact cylinder is detected by recognizing the mechanical position of the crankshaft, camshaft valve, or the distributor shaft. Operation of a camshaft position sensor. Inductive sensor. The inductive type camshaft position sensor is recognized by the two wires that it contains. This generates its own voltage and alternating current sine wave signal. So this one, unlike in the crankshaft, the camshaft signals looks a little bit more jittery. That's because it has more time to spin much faster than the crankshaft. Okay, next. As it's near the camshaft, which has a permanent magnet device attached to it, each time the magnet passes through the sensor, it magnetic field produced, and the resulting pulse is sent to the ECU for processing. So, same principles as in the crankshaft sensor. Hall effect sensor, where this type of camshaft sensor has three wires. The first wire is for its reference power, the second is for its ground, and the third for the signal voltage to be sent to the computer. It has a screen with a slot and a magnet mounted on the shaft. When the screen moves between the magnet at the sensor, the sensor is turned on and off. As long as the screen has a solid area in front of the sensor, the feedback voltage is interrupted as the magnetic field split. So again, same as the crankshaft position sensor. So this is the AC output. This is the one that I was talking about. These are specific types of camshaft position sensor that generates an AC voltage signal as on output. The ECM generates a very high frequency of 150 to 2500 cycles for the exciter coil, which is located near the rotating disc. So this one actually outputs AC signal instead of it like a magnetic field that can output AC. This one just outputs AC electricity. Thanks for listening.